Hey guys, so today I'm going to go over pattern matching in Rust. I'm saying that I'm pushing it because I'm using it where you probably wouldn't want to, but just to illustrate the difference between a pattern match and a switch and why having pattern matching in Rust is so impressive and really changes the way you can think about programming, introducing a lot of those functional ideas that have almost existed in the shadows of the programming community for a while, at least in the mainstream, and really bringing them to a wider audience. So, just some background on pattern matching in Rust. It's borrowed from OCaml. The Haskell users can see about that. I think that there's a fair argument for either one, but I prefer OCaml, so I'll go with that. And it's one of the things that sets Rust apart from other quote-unquote normal languages. And Rust is a high-functioning functional language, and by that I mean it's practical at scale. It's used in the mainstream more than most other programming languages. At least it has the most buzz. It's the only functional language in the Linux kernel, I think. Maybe they can take that title. And it allows you to write more declarative code compared to older languages like C, Java, C++. And the pattern matching is kind of like a switch statement on steroids. So just to go back to declarative versus imperative. So imperative programming is where you tell the computer what to do exactly. An example would be like, for this int range, do this specific thing with these ints. And declarative programming is where you tell the computer how to do something. So an example would be when a list has this specific structure, do this with the components of that list structure. And why declarative is important? I think one of the main reasons is it's harder. It's harder to understand. It's harder to implement certain things, at least in the thinking stage. So it's usually less code, but you have to think more. And I think anything that makes you think a little bit more, even as just a dummy project or to practice, is good for you as a programmer. And you have to really understand what you want the computer to do with a great level of precision, accuracy, and detail. And it's much easier to tell than to explain. So when you have to explain something, you're essentially demonstrating a complete depth of knowledge about that problem, about the task at hand. And in essence, your programming solutions become proofs. You're essentially giving a proof to the language, and the proof is somewhat proven, at least partially, if you get the right answer back. And I think that's why programming languages like Haskell, based on lambda calculus, are so prevalent in the mathematical community. So here's a basic pattern match in Rust. Or in OCaml, sorry, and I'll try to show what makes this better than a switch statement. So here we have the match list with, and these first two are kind of like a switch statement. You don't see much of a difference. I see if the list is equal to an empty list, just return it. If the list is equal to some first value, and an empty list after it, so it just has one value. I could also do this with not having this append operator and just having the value in here, return the list. But here's where the pattern matching comes in. So I'm able to deconstruct this list, and I'm able to bind values to these variables, a, b, and t. So what this lets me do is it lets me check if the first value is less than the second value. I can determine what to do. I can recurse on the rest of the list, or otherwise I can switch those two values and then recur again. So the ability to bind values to variables and deconstruct data structures is what makes pattern matching so powerful, and it lets you write this very clean declarative code, which I think a lot of imperative programmers have been missing out, me included. And I'm glad, better late than never, that I've really started getting into some of these functional topics. So in Rust, we can do similar deconstructions of lists. With lists, it's not as powerful as something like OCaml, mainly because you have manual memory management and safety. So if you don't know the length of something at compile time, you're going to have a hard time. But with structs, I think that Rust really shines with pattern matching. And I can try to make a video on that later, but I'm still pretty new, pretty green with Rust, so I don't feel comfortable trying to teach something I don't know fully. And to this, I'm going to go back to the well of bubble sort. It's simple. I've done a lot of videos on it, but it's because it's simple, because people know it, I feel like it's good for illustrating new concepts. So here's the pattern that I'm matching. I have 3 matches, and I'm using an OR because I want the same result for 2 of those. So I have some array list, and I use kind of like a spread operator from JavaScript almost, you can think of it like that, to match against nothing, 1 thing, and 3 or more things. And this is where the logic of the bubble sort comes in. And in Rust, you can match, or you can bind a tail value like this, but because the size is not known at compile time, I was unable to do that. I'm sure there's probably a way to get it working, but again, I'm not knowledgeable enough about the language to get that working. And then here's the header. The standard implementation I found, I think on the Rust website or the Rust book website, one of those. So I just borrowed this because I'm learning the type system, and was able to get everything working fairly well, but I do have side effects. It's not purely functional, but the main goal was just to show the pattern matching. So here's the main algorithm or implementation where I have bubble. So I match against these 2 values, and then I match against the 3rd value here, which would be 3 or more. And the only binding that I can have happen here is first and second. So I check if first is greater than second, and then I know that there's 3 or more in the list, so I can safely look at 2 without worrying about index out of bounds. And I take this, I bubble it, and I make it a new vector or collection. Sorry, not collection, array. And then I append it onto the answer. So here's the recursive call. And this is pretty inefficient, especially where it is, but again, just to illustrate the use of pattern matching. And then I extend out from there. And then here, otherwise, what I do is I just have a vector of the first element, and then I bubble on everything else. And again, what's a little frustrating is because I can't have that tail element, I have to use something that is a bit more imperative in structure. And then from there, I know that the largest value is at the end of the list once this bubble is completed. And then the actual implementation, I just make sure that the list hasn't changed, and then I return the list back. Because once bubbling the list hasn't changed it, I know that it's fully sorted. And then here, I just have some examples for the 3 different things we pattern matched for: an empty list, a list with 1 element, and a list with 3 or more elements. So here, this would be F, S, and then all of these variables would be unbound, and they would just be represented by that ... syntax. So here, if I run these, we can see perfect. We get the exact results that we expected. Although it may not be the most efficient, it is properly pattern matching everything. So that's everything for today, guys. Hope that helped. If you want to see anything else, functional, Rust-wise, in a different language, let me know. I've been looking at Babashka a little bit with Clojure, and I might make a quick video on that, or even a video about how there's too many programming languages and it's too hard to choose. You can't even choose a runtime for one of the languages you want to learn. But that's it for today. Thank you, guys.